Consuelo, everybody. Okay, here we go. This is going to be long. I'm not going to be writing anything, okay? It's all written in front of you. I just kind of want to go through one problem in excruciating detail. When I actually start doing them, in the next video where we go through examples together, I can't possibly go slowly through those. Well, I could possibly, but it would take me a year and a day. So I'm going to go through this one slowly. Okay. So again, few preliminary comments. Remember that simplifying and factoring are not the same thing. What we are doing here is factoring, not simplifying. We're pulling it apart into things that are multiplied. Okay? And remember, you can only use the quadratic formula with polynomials of degree 2. So what we're talking about here today is polynomials of degree 3 and greater. But you can only use the quadratic formula for polynomials of degree 2. Okay, I assume you already know how to solve polynomials of degree 1, polynomials of degree 2, and polynomials of degree 3 that factor by inspection. So the rest of this is what you do when you can't do any of that. All right, so fine. So let's take a look at this. So what we're going to do is we're going to try and solve this. So first of all, we're going to try and factor this. So is there a greatest common factor? No. Difference of two squares or a trinomial? No. Perfect cubes? No. Okay, we could try factoring this by grouping because there are 4 terms. It doesn't. So what are we going to have to do? The only thing left to us is divide and get a remainder of 0. That's it. Okay, if you don't understand that, nothing else I say matters. That is the thing that solves this problem. The only problem is we don't have anything to divide by. Okay, so what are we going to do? We're going to make a list of all the factors of 18 and all the factors of 2. So the first thing here, P, are all the factors of 18, Q, all the factors of 2, and I've written all the fractions P over Q, okay? All right, now, as of right now, we don't know any of this. We don't know if anything actually works. If you're not dividing, okay, you're not doing what you need to do. Okay, so what do? We just go through one number at a time until we get a remainder of 0. Don't go through all of them, okay, unless you have to. As soon as you get one that works, you write divisor times quotient. Okay, so first of all, we're going to test the number 1. Okay, that gave us a remainder of -10, so that's not a root. We're going to test, I'm just going down this list up here. I'm going to try 1, -1, 2, -2, 3, -3, 6, -6, 9, -9, blah, 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 until I get a remainder of 0. Okay, I test -1. That doesn't give me a remainder of 0. I test 2. That does not give me a remainder of 0. I test -2. That does not give me a remainder of 0. Okay, I'm not going to keep going down through the list, but what happens is I go through 1, -1, 2, -2, 3, -3, 6, -6, 9, -9, none of these, et cetera, 18, -18, 1/2, -1/2, 3 halves. It's not until you hit 3 halves that you get a remainder of 0. Okay? So what do we have? We have 3 halves, and you get a remainder of 0. Now, there's something somewhat dangerous about what I've written right here, and that is I wrote the quotient. Really, you shouldn't do that, and I'm getting to that in the next line. Really, what you should always do is write the divisor first, and then the quotient, okay? Not quotient times divisor. It's divisor times quotient, all right? So that's what I've done here. I just kind of left this blank up here just to emphasize it, okay? So we have divisor times quotient, and now factor by inspection. Okay, this is a quadratic. We can factor out a 2, okay? And then, so we're left with this times that. Now, if I could factor that, I would. The only problem is it doesn't factor. Okay? Now, so what do? I use the quadratic formula. Okay, so what do I do now? I write this part of it, which is right here, and I take these and I write them as factors. And again, if you have the 0, how do you write the factor? X minus the 0. And remember, this is 2 zeros. This right here represents 2 zeros. Negative 3 plus square root of 15i over 2, all over 2, and negative 3 minus square root of 15i over 2, all over 2. So I'm going to take each of those and write x minus the first one and x minus the second one. That is it factored. And unfortunately, Alex really is deficient here, okay? It doesn't make you write the factors. I am going to make you write the factors. You should know the difference between a factor and a 0, or a factor and a root, okay? So these are the factors. The roots are this right here. And I'm going to make you write both. Unfortunately, Alex does not. Okay, that's it. That's one problem. It obviously was a lot faster than it would have really taken, because I only went through what? Up through negative 2, right? But you'd actually go through 3, negative 3, 6, negative 6, 9, negative 9, 18, negative 18, 1 half, negative 1 half, 3 halves. And it's not until you hit 3 halves that you found one that actually worked. So what do? It's divide and get a remainder 0, then write divisor times quotient. And quite frankly, that's it. Okay? This list right here is all nice and everything, this list up here, but if you're not dividing and getting a remainder 0, it doesn't help you to have that list. All right, next time we're going to just take a look at a bunch of examples. Bonsuelo, everybody. Have a good day. You know, aren't you just kind of saying to yourself, I think I'm going to take a sneak peek at the next video because this is so exciting. I just can't wait. I understand. Have a good day, everybody.